All right, we're going to talk about architecture. I think architecture is one of the hardest things for students to grasp. I definitely get the most questions on architecture. I think part of that is because it's not a standard that we cover in depth. A lot of our stuff is based on particular game engines, so we don't go into detail with architecture, but it is important for you to understand how it's used out in business. So first of all, you need to know what architecture is. Just like the architecture of a building, architecture is really the organization or structure of the software system, okay, of our game that we're making. It's kind of the blueprint, okay, for the system and the project that you're developing. So you choose your architecture based on a lot of reasons. When you're developing software, you're going to look at the scope, so the time that you have, what your business requirements and stakeholder needs are. So what does your management need to see? What do your users need to see and all that? Obviously your budget and available funds and all of that. So all of it goes into it. For us, we are looking at all of those things when choosing our architecture, even though the majority of our architecture is decided by the type of game engine we're going to use. So for those of you that are second, third, fourth year students, you may choose Unreal Engine or Unity. So that's going to involve a different type of architecture rather than GameMaker because they all have different things within them. So for our architecture, the engine is really what determines a lot of the things within our architecture. It's also important for you to understand that you can really lay out architecture a lot of different ways. There's not one right way to do this. You can make it any color, any template, any shape, whether it's circles or rectangles or blue, white, green, it doesn't matter. So there's a lot of different ways that you can do this. I'm going to go over just a few examples of them, but you can do this completely different from what I'm showing you. So I give you a few links. I would highly recommend you looking through these links just to really try to get a grasp on architecture. I really want you to understand that it's the structure of what you're building. Okay, it's kind of those behind the scenes things that's going on. So I give you some examples. The one here, this is actually based on Unreal Engine. You can tell that because it says Havok under the physics section. Havok physics is actually Unreal Engine's physics, okay? That is their piece of it. So that's how I knew this was based on an Unreal Engine game. So all of this is based on Unreal. I give you some things for Unity. Unity's physics is called rigid body. Now these are just names that the companies that built the software, that built Unity, that built Unreal Engine, decided to name their physics system. Okay, so Havok is just a name. It doesn't mean anything. It's a name that Unreal Engine or Epic Games uses to call their physics system. Rigid Body and Rigid Body 2D, once again, they're names that Unity is using to represent their physics system. Graphics. So for us, we're working on Windows PC. These game engines all are going to run off of DirectX technology, okay? Obviously the version is going to vary. The one out right now is DirectX 11, DirectX 12 just came out. So it depends on when you're taking this. You'd want to look up what is currently out there. But it's DirectX technology. So if you're not sure what DirectX technology is, I would highly recommend you Google it sometime. But basically, it's an API, which is an application programming interface, that handles different multimedia tasks. Okay, so your audio tasks, your graphics tasks, your AI, these different multimedia tasks, particularly in game design, okay, for Microsoft platforms. So we're working on Microsoft Windows PC, so that's one of the reasons. And we're working within these game engines on it, and it all is already defaulted to use DirectX. And DirectX enables the programs that we're using to easily determine the hardware capabilities of the computer you're on, and then set those program parameters to match. Okay? So this allows different multimedia software programs to run on any Windows-based computer with DirectX compatible hardware and drivers. Okay? So I know that all sounds a little confusing, but I do want you to understand that DirectX is what is enabling these programs to run. Now, you might see different things listed when you see DirectX. I want to point it out. Here, it's just a basic DirectX 11. But down here, you see Direct 3D 9. Direct 3D is a part of DirectX. DirectX just says, basically, this is all of the direct programs, okay? Which is Microsoft Direct Draw, Microsoft Direct 3D, Microsoft Direct Sound, Microsoft Direct Music, Direct Input, and so on, okay? So they're all a part of DirectX. So for my examples, I just say DirectX. You don't need to put Direct 3D because it's graphics. You don't need to put Direct Music because it's audio. Just use the generic DirectX 11. If you want to go into more detail and use the specific Direct 3D for graphics, Direct Music for audio, you can. That's fine. But it's all a part of DirectX, and that's the important piece of it. And once again, DirectX is just enabling our program to determine what our hardware capabilities are. That's all. Okay? So it's a behind the scenes function. It's not something that we generally think about, but it really is kind of what makes these games possible. Okay? So that's important to understand. And it's important to understand that we're doing it this way because we're using Microsoft platforms. So if I were to ask, or a judge for the competition were to ask, why did you choose the architecture you did? You should know that you chose it because some of it is predetermined by your game engine, which is what we're talking about now. Some of it is determined because we're on Microsoft platforms like Microsoft Windows, okay? And some of it may be just because that's your time frame, your scope, right? So you might be using all of Unity's information here, and when they ask you why you chose it, you're going to say, well, it's determined by my game engine, and I chose Unity because I have experience with it. You know, I'm a third-year student. I felt comfortable enough that I could pull it off and try something new. Or, hey, I use GameMaker. I'm a first-year student, second-year student. I really felt like with the time we had and the scope that I wanted to do, GameMaker was one of my only options that I could pull it off. So know that that's important. Okay, you have to know why you're choosing this architecture, and hopefully you have reasons behind why you chose it. So this is just one example. Now this is broken down by what's within the engine and the system itself. And then you'll also notice that it has this interface in the middle. I wanted to show you just briefly what an interface is, and I think this is a great graphic to show that. All an interface is an intersection between two things, okay? So in this representation, it's the interface, it's the intersection between the system and the environment, okay? So it's just that boundary between two things. So you don't have to know, you know, a definition for interface, but I wanted to point out that's why this is here, because I do get that question a lot, like what is this interfaces? So that's just kind of the boundary between everything. So in this case, it's the boundary between the engine and the system itself, right? So you can use these same things up here for your game. You can. Every game has scenes, which in Unity are called scenes. In GameMaker, they're called rooms, right? Every game has objects. That's what we're attaching our coding to, right? It's where we put our coding. And then the scheduler. So that's basically scheduling what's happening now. So that's a lot of your coding that's going on there. And then the managers here, task and state. So task being the individual tasks that are happening throughout the game. So a player movement, a player projectile, a player collision, and so on. And the state of the game is the actual state of the game. Is it playing? Is it paused? Is it exited? Is it saved? And so on. So what state is the game in overall? So you can absolutely use those same things no matter what engine you're using. But because there's so many options for architecture, you don't have to include those things, but you can. Now this bottom section is what's going to change based on the game engine you're using. So if you're using Unreal, it'll be similar to this, but like I said, you don't have to put Direct 3D, and certainly Direct 3D 9 is an outdated version, so you would probably do 11. But Havok Physics is Unreal Engine's physics system, so that would not change. For your user input, that's going to depend on your game. So direct input, what does that mean? Direct input means the customer, okay, the user that's playing your game is actually doing something to make their character on the screen do something. So that may be a click of a mouse or moving the mouse, that may be arrow keys or WASD, or that may be using a gamepad. Okay, actually hooking up an Xbox or PlayStation gamepad and doing it that way. So you have to decide what to put here. You shouldn't put keyboard and mouse unless your player is required to use the keyboard and mouse. If they're only using the WASD keys the entire game, you would only put keyboard. Same if they're only using the mouse to direct their player around, you would only put mouse. So that's going to be specific to your individual game. AI. I get that question. What is AI? So AI is artificial intelligence. For your game, that could be very advanced. There could be a lot of chance going on and a lot of options. Or it could be as simple as your enemy AI that starts attacking your player when it's so close to the enemy. Okay, so it's just your general AI, your general artificial intelligence, which is run by DirectX. In our case, currently, it's DirectX 11. Same with your graphics and your audio. Okay, those are ran by DirectX 11. You don't have to put Scene Manager. Scene Manager is what Unreal Engine calls it. But depending on what you're using, GameMaker really doesn't say Scene Manager. So you can just put DirectX 11. There's not a Scene Manager necessarily in GameMaker. Now for Unity and Unreal, there are specific scene managers, and when you're in there, you can open up that scene manager and change things around. GameMaker just makes things a little more simplified. Now, when you look down here, this is a completely different version, right? Other than there being boxes, this has very little of this information. And this is what I'm saying by make it your own. It can be many things. So the architecture of this game, they have everything from their game engine, right? Which they break down even further. They don't just list it as objects and things. They actually break down that they have text, animations, sprites, textures, sound, all that. That's great. You can absolutely list it that way. You can even list it in this same format. If you do graphics, pipeline, and sound, you may want to add on DirectX 11 to that as well, since that's what managing it, but it's your choice. And then up here they have their inventory, menus, stats, save, load. So this is kind of what goes in before the game actually begins, right? You can do it this way, absolutely. And then hardware being your actual computer hardware, which they don't list, they just say hardware, because that's a piece of your architecture. But you don't have to list all that out. This is an example for a basic Android game. So once again, totally different format, but you have your user input, which is our, in this case, because it's Android, it would be touchscreen. You have game logic, which is all of our programming and stuff. And then they just simply say audio and graphics. They don't even have it broken down to DirectX or whatever this game happens to be running on. But they do show that all of this is ran within the Android framework and that everything from input to output is done on the phone. Okay, so they are showing that very clearly. So if you're doing a phone or an Android-based game, this is a great way to do it. Once again, you can get more specific. You can say audio and graphics and list the specific things that are doing that, whether it be DirectX or something else. So you can get more specific, but you don't have to. The other example I wanted to show you is this. This to me is a great example. It's so simple, but it has everything within it. Okay, once again, you have your input. So instead of just input, you could easily put input / keyboard here. Okay, and then you have your entity management, which in our case could be GameMaker Engine. And all of these things are ran within that engine, right? So AI, physics, sound, you can do each of these separate and then list AI and sound as DirectX 11, physics as GameMaker Studio Physics. And then on this side of it, you would have your rendering and your media, right? You have your graphics or whatever, but you may not have networking. Okay, so your game may not have any networking online capability, and that's fine. This would only be if it did. But this gives you, I think, just a more simplified version of it. And it's a good example because it looks totally different from the others, but I think it's very clear here what's going on. So you have player input, you have your game engine that's running everything, and then you have all those things that go into it, like your AI, physics, and sound, right? So it still represents everything very clearly. But one of the main things I want you guys to recognize here is that there's not one way to do architecture. If you Google software development architecture, you're going to find so many examples, so many different options. And I want you guys to make this your own. What I really want is for you to create your own version of these completely. Use mine as a guide, but start from scratch so that it really does show your comprehension of the things that go into a game. But use this as your guide to be able to do that. Okay, hopefully that helps explain that a little better, a little more clearly. I know that was a lot of information, but architecture really is so important, and it's not overly complicated. It just seems that way when we're looking at it from afar. But as you guys get more familiar with GameMaker and DirectX and these different things, hopefully it'll start to come together for you. But the main thing really comes back to this basic graphic. You have your user input, and then you have your output that involves all of these AI, physics, sound, coding, and all those things that go into it. So, you know, if you want to simplify it, simplify it. It's better for you to be able to describe what's going on in your architecture and really understand it than to kind of make it up and not be able to answer questions on why you did certain things within your architecture. So please keep that in mind. Any questions? Come and see me.